In this video, we will study this quick blog on ranking evaluation metrics for recommendation systems, right? So just to formalize, the recommendation system given an attribute, given a user will rank few items according to that user, right? That's the predicted value. And then we will have a relevant score of how relevant was this ranking. That's the actual value, right? So our actual value is relevance, which could be like a rating of 1 to 5 for movie that the user has historically given, or whether user has clicked an item or not, right? Binary and ordinal. So that's our actual value is the relevance score, and our predicted value is the model predicted rank, the rank. So HR hit ratio is metric number one. It is basically, so if a user has been recommended 5 items, and likewise we have done 5 recommendations or L recommendation for each user. We need to fix this parameter L. Here we have taken it as 5, right? So if we have say 10 such users, hit ratio is basically that for out of all of these 10 users, for how many of these was the correct answer included in the top L, which is the top ranked answer, right? Which should have been the, which has the highest relevancy score, right? So for 10 users, if for 7 it has been, and it's like 70% hit ratio. Mean reciprocal rank. So it is again, as we see, averaged across all user. And here we see that earlier we were just talking about if it is included or not, right? Here we take the actual relevance score and divide it by the rank, right? So if a highly relevant item which had a rating of 5 is at a lower rank, like 1 or 2, it is better. RR will be higher, so MRR will also be higher. So this basically just took the relevance score into account, MRR. MAP is mean average precision. So precision and recall we already know, right? So we'll need to define few terms to come to the value of MAP, right? So first one is precision at K, which is uh, basically, if we say top K, if we fix the K recommendations, let's say 5 recommendations, what are the fraction of relevant item that were there in top K, right? So if you see, we can have precision and recall values for top K, and we can have a sort of a graph as well of a precision recall graph, right? So MAP is just the average precision, right, for each user. Again, if we see, MAP is average of AP of U across all users, and what is AP of U is for all possible values of K. Like if we select n ranked items from K equal to 1 to n, what was the precision of that particular item, and what was the relevancy score, which we know from actual data, right? So that will be AP, and mean average precision will be just average of those. The last one is normalized discounted cumulative gain. So we know what is gain, right? So gain is basically like if you have a relevance score, as we were saying, like 1 to 5, we want to know if this user has how many items here are there, right? It's basically the relevance score in this case, right? So what we can do is, if you have top K items, we can add these relevance scores of, which is a net relevant score of selected items. But again, if we see, these are not ordered, the ordering is not taken into account. So take in account the order, we do DCG, which is basically we divide by the rank, initial ranked items relevancy score would matter more, which is log to I plus 1. Again, what we see is we have ranked these scores, right? But then again, there is one important attribute missing. If you have a list of 5 and list of 10, if we change the value of K, this is not standardized across those, right? So standardize it across different thing. We introduce IDCGK, ideal DCG, which is similar to DCG, but instead of having the K predicted items here, we have the ideal set of K items that we take into picture, right? So which is the ideal list, which should have been the best possible maximum score for maximum ranked order score for these items, and we simply divide DCG by IDCG to have a normalized score in 0 to 1, normalized discounted gain score.